Hello guys, welcome back to another video. Today in this video we will gonna see how to download the Landsat 9 satellite data using the Google Earth Engine and how to basically filter or browse the data. So Landsat 9, recently you must be aware that NASA have launched the Landsat 9 satellite data, which is having the same set of sensors which Landsat 8 was having, to basically increase the what you can say temporal resolution. So combining Landsat 8 and Landsat 9, now the revisit frequency will be 8 days. So Landsat 9 is having 16 days, Landsat 8 is having 16 days, but combining these two, the revisit frequency will be 8 days. And also they have basically, this is the legacy series, so they have just continuing that legacy of the Landsat satellite so that this data can be used for the various application. So it's having a similar kind of instrument, but with the little bit of improvement, such as I think in spectral radiometry, I think they have improved a bit, and signal to noise ratio also they have improved. So you can go on the USGS website. Now the data has been made public. You can go on the USGS website, you can download the data, then you can download, you can stack, you can cut the data for your region of interest. So that's a pretty 2-3 steps are involved, but using the Google Earth Engine you can very quickly browse the data and you can search and you can download it very quickly. So first of all, you have to register for the Google Earth Engine. So if you have Google account, just go on the Google and type Google Earth Engine and you can register for that. And after that registering, you'll get confirmation on your email. Then you can go to this link, earthengine.google.com. So here there is an option platform. You just click on the code editor. So it is free to access, anybody can use. So like this is the center one is basically for writing the code. Left one is basically you can save your scripts, whatever code you write, you can save those scripts here. You can upload your shape files and raster files here. I have uploaded so many files, so you can use those in your scripts. And this is the console, your results and everything, your task downloading and uploading will be here. Inspector, whenever you click on the map, it will give you the information about the layers. So right now I think Google Earth Engine, they have not given documentation for that, but what we will gonna do, we will basically use the Landsat because the sensors are exactly same, so we'll use the information of that only. So what we'll do, we just go on the Google and type Landsat catalog Earth Engine. Just go on Google, so you'll get this Landsat collection Earth Engine data catalog. Just click. So as you can see here, up to Landsat 8 only information is available, so we'll use the similar information because the sensors are same. So just click on Landsat 8 surface reflectance and just copy this ee.image collection. For accessing the data we have to use this thing, and all the bands and list, everything is there. We will later on use this thing. So here we'll just create one variable like collection, and simply we will type this thing. Okay, so now using this you can access the whole collection of Landsat 8, but if you change it to 9 here, so now we will access the Landsat 9. This is the level 2 product. After that we can basically we can filter the data based on the date. Just write filter date. So here you can write the date between which you want to filter your data. You will search the data. So I will write this between 1st February to 19 February. So this is it. Now if I'll print this collection, now if you run this code, it will show you all the images between these two dates. Like here in the console it is giving image collection. Okay, so it is saying so many images, lot of more than 5,000 images you are accumulating. So further you can also filter based on your region of interest also, you can do that. So let me just make it 10 of February. So as you can see now, between 10th February and 19th February, image collection Landsat 2130 images are there. If you click here on features here, so you'll be able to see so many images are there of Landsat 9. So now based on the region of interest also further we can, so there are two ways you can upload your shapefile here, and you can push your shapefile here, then you can select, or otherwise there is another way. Suppose I'll make one rectangle here. So now this geometry is here. You can make it you can let it be geometry only. You can give any name, you can change the name, and you can make it ROI, your region of interest. Okay, and here further you can write dot let me check what we have to write. Filter bounds, you can use filter bounds, and you can write here ROI. So now you can make it 01 also, because for particular region it will filter the. So now if you click here, so based on the region of interest it will filter the data. As you can see now only 12 images it is filtering. So based on this, another way of doing is you can upload your shapefile here. If you have region of interest, you can go on asset here, upload your shapefile. You can upload select your shapefile here, and you can give any name and you can upload it. So those shapefile will come here. Like I have uploaded several shapefiles, as you can see here. Simple as that. Like this is India district, India state. So further, after uploading, you can use like this. You can basically, after uploading, like as a user K90 India state merge, so this is this one, and after that you can further filter based on the basis of the attribute state name Rajasthan. So you can use, if I use ST here, so now it will filter based on this one for this particular state. Okay, now 28 images are coming for this particular state. So I will show you both the cases. ROI. So after that, now we have printed it. So now what we have to do, basically you have to for this collection you have to basically composite the data. So if you go on Google Earth Engine help, so there is an option for you can create the median of image and everything like this. So first of all, we will use these band information for converting this data into the reflectance data. So under that catalog, from where we have copied the collection link, this one, this is the basically information about the band. So we have to scale the data. We have to multiply the band with this value and offset add this value to create into the reflectance, to convert it into a reflectance. So we will use this code for that, this function. So we will just use this function directly. So this is for thermal bands, and this is for, so we will not use thermal bands, so we will use SR_B, basically these ones. So we will use only these bands, these one, like blue, green, red, NIR and so bands. So we will use these bands only. Okay, so simply we will use this particular line of code, this function. We will run this function over each and every image of the collection. So this collection, we will make it collection here. So dataset is a collection.map apply scale factor. So in all these images which are falling under the region of interest, it will basically pass all the images to this function. So it will multiply with this value and it will add it will add this value. So basically it will be converted into the reflectance values. Okay. Script. Okay, so now this we have applied. So dataset dot collection. After that we can create here where mosaic of your, you can give mosaic, or maybe let me give some name, image equal to dataset dot mosaic the dot clip ROI. So what we are doing here, after converting all the images to surface reflectance, we are mosaicing it for my region, all the images, and we're clipping it to ROI, which we have drawn here. Or we can use basically this shapefile also, which I have imported, this one. So like right now we'll do for this ROI only, and now we have to add this image. For adding this image we have to give some let me just copy another thing here, this visualization, this one, these 3 lines will copy, just remove this map.set center. So this is band 4, band 3, band 2. So it will open true color, and maximum, minimum 0, maximum 0.3 value. So let me just make it, yeah, true color 432. If I'll run this, just I have to change this name here to image. Just run it. So here you can see the image. Just switch off this. So this is the image for my particular region of interest. You can see this. If you just go on inspector, you can click on anywhere, you will get these values of the each bands and everything. Okay, these are the values of 19 bands. So further you can make a true color also, oh sorry, false color also, make it 5, 4 and 3, and just run it. So now it will make a false color composite. Okay, and if I change the region of interest to this one, my shapefile ST, so let me just go for ST here, and let me go for ST here. Based on my shapefile I did this basically. So it will, for this particular region, it will, for whole Rajasthan state it will clip. So if I change any name, suppose in my shapefile I'll make it Haryana. Let me check how, whether it will load the data for Haryana. This is the Haryana state. So yeah, it has filtered. So based on, you can change this, and for multiple states you can give this query. So let me go for Rajasthan only. So now this is, and based on how you are basically compositing data based on mosaic. So you just, it is what it is doing using the mosaic operator for all those 28 elements. It has just keep overlaying the images one over the other and keep on mosaicing it. So there is, when overlap is there, so later image will come over the earlier image. So there is no anything mean, median, anything. So we can change this, and we can use median also, median, mean. Let me just show you. If you just make it here median, so it will create the median image. So wherever overlap is there, 5 images are there, it will create the median of 5, all the 5 pixels coming one over the other. Just make it mean. So that's how you use it. You can create mean, median, max, min, like this. So I prefer to use mosaic. Let me just go for mosaic. And after that, what you can do, you can create the NDVI also, like here. After that, what I can do, I can make a where NDVI is equal to image dot normalized difference. There is a one function called let me just copy paste. Yeah, this is the one. Normalized difference, just you have to give the NIR band and red band, so it will create, rename, you can rename the band NDVI, so it will create the NDVI of it. After that, you can basically give the parameters for NDVI also. Because we have to visualize the NDVI value also, just you can like this, just where. So this is the NDVI palette, these are the colors, and this is the NDVI. So map.add layer NDVI, minimum and maximum value you can give. So as you must be knowing, NDVI is between -1 to 1, so we'll make it 0 and we'll make it 1. And palette, we are giving this color, and after that let me just add this. So now two layers will be there, one is NDVI, one is, let me just make it down below this. So as you can see, now we have NDVI image also, and we have our satellite image also. See, this is our false color composite, and we have NDVI over this. So if you go on inspector, if you click anywhere, so it will give you the value of NDVI and both the images. See, NDVI is 0.6. So further you can scale this NDVI also, because when you, so for downloading, let me just go and there is an option for called export. Okay, let me just go to my another one. I can copy from. So this is the NDVI value. So let me just go for export function. Yeah, this is the function for exporting the data. After that, you can further, if you just add this export, just give the image which you want to export. Suppose you want to export NDVI, so you can give NDVI name, like this is your NDVI, and then if you want to export image, you can type image. Image scale, you can give, this is the resolution, so 30 meter, this is the maximum pixel, and region you have to give. Region, let me give ST. So this I am giving, otherwise you can create a region of interest here. So if I run this, so as you, if you go on task here, you can see here task for downloading this data. Okay, this name we have to change. You can give this name Landsat Rajasthan. So you run it. So under the task tab, this is, you can click run here. So you can give in what coordinate system you want, EPSG. Let me go for 4326. So it will upload your drive. You can give the name here GeoTIFF. So when you run it, so it this image will be uploaded to your Google Drive. You can download from there. Okay. So if I run this, so now it is downloading. So let me cancel it. Similarly, if you want to download this NDVI, just write NDVI here. Image, this region is that, you just run it here. So now you can download the NDVI. So this is the code for exporting your image. So this is how you can download the data, and you can make a mosaic. And also from here, what you can do, you can select bands also. It will download all the bands. You can dot select. There is an option called let me show you. Like this, you can use this select band. So for particular bands only you can select. Suppose if I write dot clip here, so I can give only few bands, only two. But you band you want to download, just give the name of two bands, surface reference B5, B4, B3. So let me go for SRB2, SRB3. So like this, you can give the number of bands which you want to download if you select. Otherwise, it will download all the bands, whatever you are having in the Landsat satellite data. That depends on you. So and you can save this script as, just click save as, give any name test Landsat 9. So you can save this. So this is the one way of doing it. Otherwise, you can make a composite of greenest pixel also. So let me show you how to do that. There is one more function we can use. This is the function. These are the 3 lines we will use for creating a greenest pixel composite. Basically, the greenest pixel it will give. So here, instead of doing this, we will make one more function like this. Okay, this is our function. It will create the NDVI. Here you have to just give the name of the band. This is our band, 2 bands. I will change this band, NIR and red. These are our 2 band, dot rename NDVI. So this function we will run for all the images, all the collection. So this is my data set. On this data set, after scaling it, convert into surface reflectance, I will simply apply this function map.add NDVI, this function to this data set. This is now greenest. Greenest is equal to with NDVI dot quality mosaic NDVI dot clip. You can give your region of interest here, ST. So now this is my greenest pixel. So I will make this as a comment. Let me just go for this. Here, instead of image, I will make it, write it greenest dot NDVI. So now if I run this, and here I have to add greenest. Okay, now if I run it, greenest is not defined. Okay, double E, should be double E. So now this image will be the composite of all the images between these two particular dates with maximum NDVI. So basically, to remove the clouds, you can give a 1 month data and you can make a maximum NDVI composite like this, and after that you can create the NDVI out of it. So this is the greenest pixel composite of this. So suppose for whole India you want to do, what you can do, if I remove this filter, I have whole India shapefile. So if I make comment of this and I'll just do this, so you just see it will create a composite of whole country, but it will take some time, as you can see now. So whatever pass is available over the whole country, it is creating NDVI for that. You can see here. So that's how you can basically, so just upload your shapefile here, and then you can, based on your region of interest, you can do. Otherwise you can draw the shapefile like I have drawn here 4 polygons here. For that you can do this region. If I replace ST with ROI, so for this it will create everything, NDVI and everything. So I can further save as Landsat 9. renest. Okay, so now you can see this is the pass between these two dates for whole country like this. So what I will do, I will basically share this code for both these, for greenest pixel composite and for that also for simple mosaic. Only you have to change your region of interest, all this wherever this ST is there, you just change that, or ROI is there, you just draw your, you have to change that. Like here you have to change this one, and for downloading also you have to change it here. So this is how quickly you can search the data for a very large area and you can download it very quickly. Suppose you want NDVI only, so you can create NDVI and you can download. Further, for NDVI, what you can do, because this NDVI is float, so it will be very like the size of the image will be very large. So further, what one can do, you can scale this NDVI after creating the NDVI. Like here you can scale it, you can multiply 100 and divide by 100 like this. Let me show you. Like this, unsigned 8-bit you can do. You can create scaled NDVI, sorry, let me just paste it, NDVI dot multiply by 100 into 100 unsigned 8-bit. So after that you can just under visualization you can change it to NDVI underscore scaled, and your value will be minimum will be 100, it will be 200. So if you run this, let me just make for a small area. So now your just make, okay, you have to remove this token from here. So now if you run this, so your NDVI will be scaled one, not float. So unsigned 8-bit, so you can very quickly download this. It will be, the size will be much smaller. Click here, so your NDVI value will be 173. So it means it is 0.73. We have scaled it to 170 into 100 plus 100. So like this one can do. So I'll save this. So I will share this code. What I will do, I will share this link from here, get link, and I will just share this link so you can access this link and for downloading data for your area of interest very quickly. As you can see, you can zoom in, zoom out. Further, you can do the classification after filtering this data. You can do the classification also. I think maybe in some later images I will show you how to do the classification, how to create the classes. Random forest and SVM 2-3 machine learning algorithms are there. So you can use multi-date data for classifying the the satellite data for land use land cover mapping. So, and similarly, if you change these for Sentinel, you can download for Sentinel, then you have to change these band names also based on the Sentinel. So you can change that. Earlier already I have one video, uploaded one video long back for Sentinel data. You can check that video out also. So I think that's it from this video. Hope you liked the video, and please give a thumbs up to the video, and please, if you face any problem, just put a comment. So I'll try to reply as soon as possible. Thank you. Thanks a lot. Thanks for watching this video.